What I have here is a surprise party. Yes, these three people have just walked into a party thrown just for their excellence in chemistry. Now, what I have here are these three people's reactions to the party. So, this person over here is genuinely happy about the party. He's overjoyed. Now, this person over here, he's actually genuinely surprised. He had no idea that this surprise party was going to happen. And this one over here is just downright angry that he had a surprise party at all. How is he going to clean up this surprise party? It's just going to be a giant mess, and he really was having a bad day. He didn't want a surprise party. Unfortunately, we're not going to be talking about these reactions here. We're not going to be talking about these reactions. No. We're going to be talking about these reactions. We have precipitation, combustion. We have synthesis. We have decomposition. And all of these are all just reactions. These are called reactions. Actually, these are types of reactions. So let's amend this. Types of reactions. These are kinds of reactions that we can have. Now, what I have are just four of them. We're going to be going over actually much more than just four. We're actually going to be going over 1, 2, 3, 4, 5, 6, 7, 8 different types of reactions. Eight reactions. And just their general forms as well. So let's actually start with the first one on the list, which is precipitation. Let's start with precipitation. Now, what is a precipitation reaction? Well, a precipitation reaction is just for the definition, a reaction in which two soluble, so a reaction in which two soluble solutes react to form an insoluble product. Now, we talked about solubility before, so what these words soluble and insoluble mean. But just a quick recap, soluble means that they're able to be dissolved in water. Can be dissolved in water. And insoluble cannot be dissolved in water. Alright, so that is the definition of a precipitation reaction. Now let's look at this in a more practical sense. When we look at a precipitation reaction, we see two soluble solutes. So let's think of our own reaction. Let's take an example. Let's see. An example of a precipitation reaction. One example would be, let's say, the reaction of lead nitrate, so PbNO3, reacting with potassium chromate, K2CrO4. And that gives us lead chromate and 2 potassium nitrates. Alright, now we know that these are soluble, so I can put the aqueous symbol there. Now we need to determine which of these is soluble. Now, consulting back to our solubility rules, we know that nitrates are generally insoluble. So this is nitrates are generally insoluble. So nitrates are insoluble. However, there is an exception. We have a potassium here. Now, we know that there's an exception to this rule in which potassium nitrate is actually soluble. So I can actually go ahead and cross off insoluble because this is soluble because of potassium nitrate. So I can actually put a aqueous symbol there. Now, that only leaves one, but let's understand why. We have a rule that says that all sulfides, chromates, and phosphates and carbonates are insoluble. So, therefore, this is a solid. So this is our precipitate. This is the precipitate. This is what a precipitation reaction looks like. We have two aqueous reactants forming one aqueous product, or at least one, and at least one precipitate. So this is the precipitate. Let's move on to something else. Let's move on to the next one. Now, this is actually fairly easy to understand. The next reaction, which I'm going to go for, is called the synthesis. Another name for the synthesis reaction is a composition reaction. Composition reaction. Now, in a synthesis reaction, we basically have element A, or compound A, and compound B. Really, this should be elements, because these two elements are going to join together to just form compound AB. So, if I have lithium, and I take oxygen, and I combine them, I will create lithium oxide. So this is a synthesis reaction. Likewise, I also have the anti-synthesis. Now, that's not actually the name. The name for the opposite of the synthesis reaction is actually the decomposition reaction. And in this case, element AB, or compound AB, is actually decomposing into its two primary components, A and B. So, Li2O in a decomposition reaction would be forming lithium and oxygen, just like this. The next reaction, the next type of reaction, I should say, is called a single replacement. And at the same time, I'm also going to put double replacement on here as well. Double replacement. Because they're actually quite similar. The single replacement, the way the single replacement works is by compound AX is reacting with B, with element B, or just the single atom B, and it's forming A, just the solitary A, plus BX. So as you can see, this X has transferred now from the A, and it's gone to the B. So it's gone from the A to the B. So, for example, if we were to take the reaction, so this is the general form. Now, double replacement is actually one of the most common ones that we see. So in a double replacement, we have AX plus BY is equal, and not is equal to, reacts to form, and then basically these two are going to trade spaces, and so it's going to become BX plus AY, or rather it should be AY plus BX. But it doesn't really matter which way you order it. So this is a double replacement. So in a double replacement, double replacement, we're actually replacing both. And in a single replacement, we are only replacing one. The last type, there are actually 3 more types of reactions. The next one is something that everybody likes. It's called, if you can guess it by the picture, after I finish drawing the picture, yeah, I would see whether you could guess this. Let's see. Oh dear. Let's see. This is fire. Just as a hint, this is fire. And then we have some. So at this point, if you stop the video to take your guess, the answer is this is a combustion reaction. Yes, that means that we are blowing something up. Actually, a combustion reaction is actually more general than you think. A combustion reaction is any 2 substances that and they have to include oxygen. It must include oxygen. That's typically the standard, is including oxygen, that violently releases energy. So in that sense, and we also have things called hydrocarbons. So we have things such as hydrocarbon reactions. So C3H8 plus O2 gives you CO2 plus H2O, and then when you balance that. But you can also have metals reacting. So two magnesium react with oxygen to produce 2 magnesium oxide. That's another option. So anything that reacts violently to release large amounts of energy. The last 2 types are acid-base reactions acid-base, and then the last one is reduction oxidation. This one we won't go too much into. It's essentially a regular reaction. Redox reactions are essentially regular reactions in which the oxidation number are essentially double replacement. They're almost like double replacement reactions. They're almost like double replacement reactions in which the oxidation number of one of the elements changes. So in that sense, we're just going to go more into the acid-base reaction. The acid-base reaction is basically an acid and a base reacting to form water, so H2O, plus a salt. A salt meaning an ionic compound. Now acids form H plus ions, and a base forms OH minus ions. For more information on this topic, acid-base reactions, and you can go ahead and check out our acid-base video. So these types of reactions, it's very important to realize which type of reactions you're looking at, because it's important to know if the difference between a precipitation reaction and a synthesis and decomposition reaction. Thank you very much.